Good day, lovely people. I hope you are doing well and blessed wherever you are. Right, this is your tutor Bongani Masango. I'm back again, and it's nice to be back with Avogadro's number. All right, so let's have a look at what we have here. All right, Avogadro's number. There we've got a capital N and a subscript capital A. Na represents the number of particles. These are atoms, molecules, or ions, all right, that are in a mole of a substance. All right, so the Avogadro's number is 6.022 times 10 to the power of 23 particles per mole. All right, so for each mole you have those particles. That is 6.022 times 10 to exponent 23. So 1 mole of a substance is equal to 6.022 times 10 to exponent 23 particles. As I said before, these are atoms, molecules, or ions. All right. Now, please note it's not limited to these ones. It can be formula, it can be compound, and so forth. All right. So, example, 1 mole of carbon, which is carbon 12, is exactly equal to Avogadro's number, which is 6.022 times 10 to the power of 23. All right. So when you are working with atoms, it's going to be atoms. All right. When you're working with molecules, it's going to be molecules. When you're working with ions, it's going to be ions. All right. So now let's look at the formula that we have here. Number of moles, which has an SI unit, mole. Okay. Number of mole, which has an SI unit, mole, is exactly equal to number of particles over Avogadro's number. All right, what are these number of particles? As said, atoms, molecules, and ions. All right, so these are the particles that we are talking about. Okay, now let's look at this first question. When can I use Avogadro's number? When can I use Avogadro's number? You can use Avogadro's number when you're looking for the number of particles, when you're looking for the atoms, molecules, or ions. You can also use Avogadro's number to get the number of moles. Let's say you are given the number of molecules, ions, or atoms, then you can work backwards and get the number of moles for that substance. All right, so let's look at our first question here, which says calculate the following for aluminum sulfate. I'll remind you again that you can go back to our first videos where you can get how to name the compound. All right, so now the number of moles present in 85, I want us to do it together. The number of moles present in 85.5 grams. Okay, we are going to do that together. And I have my periodic table with me. So we are looking for the number of moles of aluminium. Okay, it was number 1. There we go. So we are going to look for number of moles of aluminium sulfate. Okay, this is a 3 will be equal to mass over molar mass. What are we given? We are given the mass, which is 85.5. Therefore, this is equal to 85.5 over the molar mass. Okay, need to work out the molar mass of aluminium sulfate. Okay, well, I did work it out. I think I got 342 somewhere there. Okay, all right, so what are we gonna do? I hope you guys can see here. Yes, maybe something like this. You are going to say number of moles, molar mass. When I look at aluminium, where is aluminium? There is 27. How many atoms of aluminium do you have? There are 2. Okay, multiply by 27. Okay, plus any other atoms you have? Yes, you do have sulfur. Please take note here. Sulfur, one atom, and then multiply by 3. So it's 1 sulfur atom times 3. So there are 3 of them. And each atom of sulfur gives you 32. Where's sulfur? Number 16. There we go. Okay, hope you can still see there. Sulfur, it's 32. So what are you going to have? You're going to have 3 times 32 plus, what else do you have? 4 times 3 is 12. So you have 12 atoms of oxygen. 12 times each oxygen atom has a molar mass of 16 grams per mole. So that's 16. 16, and then I'm getting what? The answer is 342. Can you see that? It's 342 grams per mole. All right, so it's 342 grams per mole. Okay, when you divide the two, you are going to get 0.25. So I'm getting 0.25 mole. All right, so this is the mole of aluminium sulfate. All right, question number 2 says, how many atoms of aluminium are in 85.5 grams, okay, of aluminium sulfate. Okay, so how many atoms of aluminium are there? Okay, now maybe if it also added that how many atoms are in how many atoms of aluminium are in 1 mole of aluminium sulfate. Okay, but anyway, let's look at that question, and I'm going to try and do it in 2 ways. Okay, I hope I'm not going to lose you. All right, let's start now by looking at the relating number of moles to Avogadro's number. Okay, we know that 1 mole of aluminium sulfate, okay, is exactly 6.022 times 10 to the exponent 23. Okay, and then what mole are we having here? We are having 0.25 of aluminium sulfate. Okay, how many molecules will that give us, or ions? Molecule, will it give us 6.022 times 1023, and this one will be x. Okay, so we are going to cross multiply. Okay, when we cross multiply, you are going to have these multiply by the number of moles. Okay, so this number of moles multiplied by 6.022 times 10 to exponent 23, I'm getting x to be 1.5055. I'm not rounding off because it's not my final answer. I can keep it to 4 or 5 decimal places, and then I'm getting okay, let me say molecules for now. Okay, so I'm getting 1.5055 times 10 to the power of 23 molecules of, what's this? Aluminium sulfate. All right, therefore, what am I looking for? I'm looking for the number of atoms of aluminium present in there. How many aluminium atoms are we having? We are having 2 from aluminium sulfate. Therefore, the atoms of aluminium will be 2 times 1.50 times 10. Sorry about that. 1.5055 times 10 to exponent 23. And then I'm getting what? You multiply that by 2. I'm getting 3. Can I write it here? I'm getting 3.011 times 10 to exponent 23 atoms of aluminium that are there. Okay, is there another way? Yes, definitely there is another way. If I'm too fast, maybe you can replay it again, stop it, and rewind it. All right, so what is another way? We have our number of moles of aluminium sulfate, number of moles of aluminium sulfate. We said it is 0.25 mole. All right, how many moles of aluminium are we having? All right, you can see the mole ratio is going to be 1:2. Okay, so number of moles of aluminium will be twice the number of moles of aluminium sulfate. Okay, it's gonna give you 0.25. all right, ratio is 1:2. You don't have to write this, just for interest sake. Okay, 1:2. all right, and therefore you are going to get 0.5 mole. This is the number of moles of aluminium. All right, therefore we are looking for the atoms of aluminium. We know 1 mole of aluminium will give us 6.022 times 10 to exponent 23 atoms. Okay, what about 0.5 mole? How many of aluminium, how many atoms will it give us? That's when you cross multiply. So it's going to be 6.022 multiplied by 0.5, or the half of 6.022 times 10 to exponent 23. So your x will be 3.011 times 10 to exponent 23 atoms. Okay, I hope you got that right. Moving on, there's another example I want us to do. Okay, working together we can achieve a lot. Right, so the more exercises you embark on, is the more you're going to understand this topic. All right, now let's look at the following question. It says, it's a practice question. It says, calculate the mass of 31.31 times 10 to exponent 23 molecules of carbon monoxide. Can you see that? CO, carbon monoxide. All right, so we are looking for what? We are looking for, I'm going to write my solution here. Okay, working together we can achieve. All right, so what are we going to look for? We're going to look for the mass. But what are we given? We are given the molecules of carbon monoxide. All right, we know that 1 mole, okay, of carbon monoxide gives us 6.022 times 10 to the power of 23 molecules. Remember, it's molecules, atoms, ions, depending on what is given. In this case, we are working with molecules. All right. So we are looking for the moles so that we can get the number of the mass. The moles of carbon dioxide that will give us 31.31 times 10 to exponent 23 molecules. Okay. All right. This is a very simple method. Very simple method. You cross multiply, and then you can see what's going to happen here. You are going to have x times 6.022 times 10 to the power of 23, all right, molecules, and then we'll give you, can I try and move it this side so that you can see? All right, we'll give you what? 31.31 times 10 to exponent 23 molecules times mole. There's a mole here, 1 mole. But remember, this is not really serious. I don't want you to put so much into your calculations, all right? You can just work with numbers. You know that you are looking for moles. So we obviously solving for x. Solving for x, excuse me there, and then 6.022 times 10 to the power of 23 molecules. All right, and then we are looking for, okay, so x will be, let me find out, 31.31 times 10 to exponent 23 over 6.022 times 10 to exponent 23. I'm getting my x to be 5,199. So it's x equals to 5.199. Okay. What is this? Mole. Okay, but the question wasn't looking for mole. Therefore, number of moles is equal to, the question was looking for the mass of carbon monoxide over the molar mass. Okay, and therefore the number of moles will be 5.199 equals to mass is what we are looking for over the molar mass. Carbon is 12 plus 16, that's 28. Okay, so the mass of carbon monoxide is 28 multiplied by 5,199. So the answer is 145,58. 145,58 grams. Okay, I hope you got this right. You see, it's a lot of work. Okay, it's a lot of work, but not that much, just that I've included things that are not necessary here, especially the molecules. You're just working with numbers and divide, all right? It will be easier for you. All right, guys, thank you for your time. Don't forget to like the videos, share, and firstly, you need to subscribe and click on the notification buttons. Thank you so much, and all the best with your exams.